Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good evening, class.
Good evening, sir.
How are you today?
I'm fine. And you?
I'm fine too, thank you. Okay, before we start our lesson today, let's pray together. Pray, begin. Ida. Okay, before we start our lesson, I will ask to you, anyone absent today?
Nobody.
Okay, I think this is a good thing because I come here, the class is very clean, the whiteboard is also clean, and I think you are so very excited and full of spirit enjoying this lesson.
Yeah.
May I know
Thank you.
why are you so excited and full of spirit enjoying the lesson? Can you give me the reason?
Yes, I can.
Yes. What your reason, Abi?
Because mathematics is good lesson for me. And I very interesting too.
Okay, give a plus. Oh. Because you are very excited enjoying this class, just directly, we are going to study about the differentiation. Differentiation. Or sometimes it's called by derivative function. Okay, before we are going to know how we can determine the derivative function, you have to know what the notation of the derivative function. Do you know, class?
No.
I will give you now. Suppose we have the function is defined as f of x. Okay, I make this figure in order to understand to this material. Suppose we have the function is defined as function f of x, and then we have the derivative function is f prime x. Suppose we have the function is defined as y, we have the derivative function is y. Okay, sometimes there is also the one write the derivative function dy over dx or d f of x over dx. But we always use f prime of x and y prime. Okay. Until now, is there any question?
Not
Okay, that's great. And then because you are understand about the notation of the derivative function, I just said quickly, I will explain about the ways how we can determine and how we can count the derivative function. Actually, there are so many ways to count the derivative function, but now I will just give you two simple ways. The first way we have f of x, and then we can get the derivative function is equal to f prime of x is equal to limit h approaches to 0 f of x plus h minus f of x over h. You understand, students?
Yes.
Maybe you can more understand about this material after I give you example. For example, given f of x is equal to 3x, and then we have the derivative function is equal to we can find the derivative function of f of x by f prime of x is equal to limit h approaches to 0 f of x plus h minus f of x over h. Okay, so according to this theorem, we need f of x plus h and we need f of x. You know, f of x is equal to 3x. Yes, that's great. Okay, so we have the f of x plus h, and then we have 3 times h is equal to
3h plus 3h.
Okay, that's wonderful. Okay, we have f of x is equal to 3x, and then we have f of x plus h is equal to 3x plus 3h, and then we substitute to this theorem. And then we have the limit, f prime of x is equal to limit h approaches to 0, f of x plus h minus f of x over h. And then we have limit h approaches to 0. What the f of x plus h? 3h. Okay, that's it. F of x? 3h. Okay, that's great. H. Okay. So this is equal to limit h approaches to 0. 3x minus 3x is equal to 0. And then the result is 3h over h. Because this is same, and then we get limit h approaches to 0 equal to 3. And then we have f prime of x is equal to
3.
Okay. Do you have any question?
Nothing.
Okay, so you will understand to this material.
Inshallah.
And then the second way, we can use this theorem. Suppose we have function of f of x, and then we have the derivative function f prime of x. We have the function of f of x is equal to a x to the power of n, which a is equal to constant number, and then x is the variable, and then n is the total of power. This. Suppose we have function f of x is equal to a times x to the power of n, which a is equal to constant number and x is the variable and n is the total of the power. And then we have the derivative function f prime of x is equal to n times a x to the power of n minus 1. Okay. The second way, we can use this theorem. For example, suppose we have function f of x is equal to 2x to the power of 2 plus 3x plus 1, and then we have the derivative function is equal to 2 times 2x 2 minus 1 plus 1 times 3x 1 plus 0. Okay, that's great. 2 times 2 is equal to 4. X, and then is 1 plus 3. Okay, just 3. Okay. We have the function f of x is equal to 2x squared plus 3x plus 1, and then we have the derivative function is equal to f prime of x is equal to 4x plus 3. Is there any question or you understand to this material?
Yes.
Okay, that's great. Wonderful. Okay. Anybody can erase the whiteboard, please? Okay, again. Yes.
Good job.
Okay, I will revert again. The first way we have the ways is f of x is the function, and then we have the derivative function is equal to f prime of x is equal to limit h of what is the 0 f of x plus h minus f of x over h. And then the second way, we have fx is the function, we have the derivative function is equal to f prime of x is equal to we have f of x is equal to ax to the power of n, and then we have f prime of x is equal to n times ax to the power of n minus 1. Okay. You can write this theorem into your book first. Before we are going to solve some problem from the exercise in this case. Okay. Yes? Yes. Okay. Now, open your book, The Applied Mathematics, in this material of the derivative function on page 26. 26. Yes. 26. Yes. Okay. You can look on the number of 3, the third number. We have now how to find the derivative function if the function just 1. That's what that means f of x. Example, f of x is equal to 3x plus 3, or f of x is equal to 3x squared plus 6x plus 1, or any other. And then, how about if there is function that the multiplication operation, okay. Look at number 3. How we can find the derivative function is the function is defined as f of x is equal to u times v, and f of x is equal to u over v, which u is the function. Suppose the function is okay. Now u is the function, and then v is the function. We can find the derivative function if the function is defined as that's written. We can find f prime of, okay, I'm sorry. We can find if the function is equal to u times v, and then we can find the derivative function of fx is equal to f prime of x is equal to u prime times v plus u v prime. We can use this theorem, and then when we have the function is defined as u over v, and then we can find the derivative function of f of x is equal to f prime of x is equal to u prime times v minus u times v prime over v to the power of 2. Okay. Now I will give you some example for this theorem. We have the example. You can look on your book. That's given the function f of x is equal to x to the power of 5 plus 2x to the power of 4 times 3x to the power of minus negative 6. Okay, we are going to solve this problem. We have the function f of x is equal to x to the power of 5 plus 2x to the power of 4, and then 3x to the power of negative 6. Suppose we are going to make the assumption. Yes, the assumption. We are going to assume u is equal to x to the power of 5 plus 2x to the power of 4, and then p is equal to 3x to the power of negative 6. Okay. According to this theorem, we have function f of x is defined as u times v, and then the derivative function is equal to u prime times v plus u times v prime, and then we need u prime. We have u is equal to x to the power of 5 and plus 2x to the power of 4, and then we have u prime is equal to 5x to the power of 4, and then 4 times 2x to the power of 4 minus 1, and then we have the result is 5x to the power of 4 plus 8x to the we have this function. And then we have p is equal to 3x to the power of negative 6. And then we have p prime is equal to negative 6 times 3 x to the power of negative 6 minus 1. Then we have the result is negative 6 times 3 is equal to
Negative
18. Yes, that's right. Negative 18 times x to the power of minus 7. Okay. We have this function u prime and p prime, and then we are going to substitute to this term. And then, according to the theorem, if we have f of x is equal to u times v, and then we have f prime of x is equal to u prime times v plus u v prime. What the u prime in here?
5
x to the power of 4 times p. What p here? I'm sorry, not yet. Plus 8 x to the power of 3. And then we have p is equal to
3x to the power of
Main 18.
3x to the power of negative 6. And then we have u is equal to x to the power of 5 plus 2x to the power of 4. And then
negative 18 x to the power of negative 6.
Sorry, sir. Can you change the word marker?
okay.
It's not
Yes.
wrong.
Yes, Abi.
I'm sorry.
Thanks.
No, I'm sorry.
Yes, thanks, Abi.
Yes.
Because you remind me to change the okay. I repeat once more. Once more again. What the u prime is equal to 5
5
x to the power of 4 plus 8 x to the power of 3 times what p here 3 x to the power of negative 6. Okay, then plus u is equal to
5
x to the power of 5 plus 2 x to the power of 4 times what p prime here negative 18 x to the power of negative 7. Okay, we are going to multiple every side. 5x to the power of 4 times 3x to the power of negative 6 is equal to
15
x to the power of
Negative
negative 2. Yes. Plus 8 times 3
24
then x
to the power of
negative 3. Okay, that's good. Plus x to the power of 5 times minus 18 negative 18 x negative 7. And then
Negative
18
x to the power of negative 2
negative 2. Okay, plus negative
negative 36
36
x
times x
to the power of negative 3
negative 3. Okay, that's good. And then we are going to operate the same power. And then we have the
main
14x power of negative 2 minus 18x negative 2 plus 24x negative 3 and minus 56
negative 3
then 15x minus 18.
Negative 3.
X
To the power of negative 2.
Negative 2. And then 24 minus 36.
Men 12.
Negative 12.
Negative 12.
Okay, negative 12.
To the x to the power of men 3.
Okay. Negative 3.
Yes, negative 3.
So we have the answer is equal to negative 3x to the power of negative 2 minus 12x to the power of negative 3.
Easy.
This is sum on the proof. Is this sum to the proof?
Yes.
This is sum. Okay. And then we are going to solve the second problem. We have the second problem is equal to f of k of x is equal to 3x plus 1 over 2x minus 3. Okay. And then we have k of x is equal to 3x plus 1 over 2x minus 3. Okay. Anyone from you to solve this problem? I will help. Don't worry, I will help. Some of you. Aga, you want? Or Api? Aska? Aska? Yes, Aska. Okay. You ask, why not you?
Oh, check. Check.
Okay. Okay. That's fine. Make the assumption first. U is equal to 3x plus 1 and V is equal to 2x minus 3. U is equal to pay attention to Aska.
Yes, sir.
Okay, thanks. This is not fun. Just some people. Maybe you can change side in order to lodge. Okay, thanks. I'm sorry, this is mine. I'm sorry, you can write the equals equation and then the divide. Make one line. Make one line. One line like this. Same line. Look at it. Same line. Yes. You have to write correctly. Okay, thanks. In your lesson. Yes. You get the direction? Okay, yes, that's great. Is this true, students? Okay, that's true. Because we have the function g of x is equal to 3x plus 1 over 2x minus 3. And then we make the assumption u is equal to 3x plus 1, and then u prime is equal to 3. And then we have p is equal to 2x minus 3, and then we have p prime is equal to 2. And then we have the theorem g of x is equal to 2 over p, and then the derivative function is equal to g prime of x is equal to u prime times p minus u times p prime over p squared. And then by this operation, then we get g prime of x is equal to negative 11 over 4x squared minus 12x plus 9. Is there any questions, students?
Nothing, sir.
Do you understand for this material, students?
Yes.
I think you are good understand for this material.
Yes.
I say thank you so much because you pay attention for my explaining.
Yes, sir.
Yes, sir.
Yes, sir.
Oh, we listen. The bell is ringing. Then the lesson is over.
Yes.
Okay. Because the time is over, and then before we close our meeting today, let's pray together in order to get the useful knowledge for now and for tomorrow. Amen.
Amen.
Let's pray together. Pray, begin. Enough. Okay, students, thank you so much for your attention and see you next time. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.